Welcome. Today, we're going to take a look at some examples on how to find inverse functions. In our first example, we have the function 3x plus 2. And what we want to do, we want to define the inverse of that function. Well, let's remember a key property about inverse functions which we will use. Given any value of x, if we plug it into any function, we will get a value for y. Well, the inverse function will do the opposite. The inverse function will get the y value, we're going to plug it into the inverse, and it will tell us what's the value of x that we use. In other words, the domain and the range, they switch locations. So now let's use this idea to define the inverse of f of x. The first thing that we will do, instead of writing f of x, I'm going to write it as y. And to define the inverse, let's switch the locations for x and y. Where we had a y variable, now let's switch it for an x. And when we had a variable for x, now let's switch it for y. And now that we have switched the x's and the y's, now we need to solve for the new y. So if we're solving for y, we want to isolate this variable. The first thing we might want to do, let's start by subtracting 2 on both sides. And now to solve for y, we need to divide by 3. So now that we have defined the inverse of f of x, but we have to use the correct notation for this. If the function that we started, the name was f of x, then the inverse is going to be named f negative 1 of x. And now we place the function that we found. Now let's take a look at another example that is a little more challenging. So we have the same scenario. We have a function of f of x, and now we want to define the inverse of that. Let's start by renaming our function. Instead of calling it f of x, let me call it y. And now let's apply the property for inverse functions. Let's switch the locations for x's and y's. Whenever we have a y, we're going to switch it for an x. And whenever we had an x, let's switch it with a y. And now that we have applied the property for inverse functions, now let's solve for the new y. Let's isolate for the y that we have here. Let's start by subtracting 3 to both sides. Notice that this 4 is in front of the variable. It is multiplied. To cancel it out, we do the opposite, which is division. And now to get rid of the exponent of 3, we do the opposite. The opposite of an exponential, it is the root. The exponent is 3, so we will take the third root to both sides. Now the root will cancel out with the exponent. And now we have defined our inverse function. But we need to use the correct notation for this. The name of the function that we started was f of x. So the inverse will be f negative 1 of x. And then we place on the function that we found. Let's take a look at one more example. So here we have the same scenario, but notice that now our function is called g of x, but we still want to define the inverse of that. I'm going to start by renaming our function. Instead of calling it g of x, I'm going to call it y. And now let's apply the property for inverse functions. Let's switch the locations for x's and y's. Whenever we had a y, let's switch it for an x. And whenever we have an x, let's switch it with a y. Now that we have applied the property for inverse functions, now let's solve for the new y, which we can find it here. Let's start by subtracting 5 to both sides. But now notice that our variable of y, it's inside the parenthesis, which is being raised to the third. So let's start by getting rid of that exponent. And if the exponent that we want to get rid of is to the third, we need to do its opposite, which is a root. So let's take the third root to both sides. Now the third root will cancel out with the exponent. And now the only thing that is left is to get rid of this minus 2. So let's add 2 to both sides. So let's do that over here. But I do want to notice that this plus 2 that we added in our previous step, notice that it was added separately outside of the third root. If you either add or subtract after taking the root, that addition or subtraction always occurs on the outside of the root. Now let's use the correct notation. Because our function was called g of x, then the inverse will be named g negative 1 of x. And it will be defined using the function that we found previously. So now we have defined the inverse of the function of g of x. Hello, if you would like to continue learning about mathematics, you can check out the videos on the left.